Let's start on question number 9. Okay, I'm going to move this question to whiteboard, please, and we shall begin. Okay, the line 2y equals to 3x minus 6 intersects the curve xy equal to 12 at points P and Q. So find the equation of the perpendicular bisector of PQ. Okay. So we just need to imagine the curve. So we don't really need an accurate diagram. Let's say the curve looks something like this. Okay, and then the line, just put a straight line. Let's just going one like that. Okay, it could be the other way around as well. I'm just simply drawing a representative. And then we need to find where it intersects as the points P and Q. Aha. Okay, and then what they're trying to say is, after you find this 2 points, we need to find the equation of the perpendicular bisector. What is a perpendicular bisector? It's a line that goes through the midpoint M of PQ, and then it's in the middle like that, and this is 90 degrees. The perpendicular bisector of PQ. Okay, so now let's begin with the first part, which is to find the values of P and Q. So to find P and Q, we need to solve simultaneously. Okay, we need to solve the 2 equations simultaneously. Aha, so let's have a look at the 2 equations first. So 2y equals to 3x minus 6 and comma, they say xy equals to 12. So we rewrite this. Let's say I just write it as y equals to 12 over x. Rewrite the easier part and substitute that into the earlier former equation. So let's substitute 2 in 1. So what happens? Oh, this is 2 and the y is 12 over x. Y is 12 over x. And this is equals to 3x minus 6. 3x minus 6. Y is 12 over x. So 24 equals to 3x squared minus 6x. Oh, so we bring it all to one side and we realize that this becomes, okay, let's have a look at it, please. 3x squared minus 6x minus 24 is 0. Okay, and then there's a common factor. So some of the questions have there's a common number like that. Please divide throughout by 3. So you would get x squared divided by 3 is 2. Divided by 3 is 8. 8 times 3 is 24. So 0. Then we think about it. Whether is it factorizable or not. If it's not factorizable, we can use the formula, quadratic formula. Okay. So 8 times 1. So we can see that it's possible. Aha, something like x minus 4, x plus 2. We can factorize it like that or using the calculator. So, and then we can get the 2 values. Aha, okay, let's say from this branch, put it 0, and this branch, put it 0. We get x minus 4, 0, or x plus 2 is 0, from which we deduce x equals to 4, or x equals to negative 2. Oh, and then we substitute back. So we substitute back in equation 2 because easier. So in equation 2, what happens when you substitute this back? We're calculating the y coordinate, which is common to all of this. So that means the y coordinate will be y is 12 over x, 12 over 4, or y equals to 12 over x minus 2, from which we can see that y equals to 3, or y equals to negative 6. Okay, negative 2 times 6 is, sorry, 12, okay. So there we are. Okay, let's say we just call this, doesn't matter which you call as x and y and all that. It's just a representative diagram. It's not matching it perfectly, you know. So P is 4, 3. And let's say Q is, so what is Q? Let's say negative 2, negative 6. Okay, now being that said, now we found the points. Now we need to find the equation of the perpendicular bisector. So one of the key points is we must find the midpoint. Okay, the midpoint and the gradient. So two things to go about. Okay, let's try to find the midpoint of PQ. So midpoint of PQ, let's say it is M, then we just do an average like that. M, how do you find the value of M? 4 minus 2 over 2, plus minus 2. Huh? So the other one, the y coordinate, take the corresponding 3 minus 6 whole thing over 2. How did I get the 4 minus 2? This one. So midpoint formula is we take the x and x like that. This is x1, this is x2. So midpoint will be x1 plus x2 over 2, average. So similarly, to find the y coordinate correspondingly, we take the y1 and y2. Take the average, y1 plus y2, whole thing over 2 as well. So that's what is being done up there, but just a bit more faster. Okay, let's try to complete that. 4 minus 2 is 2, 2 is 1. 3 minus 6 is minus 3. So it becomes minus 3 over 2. Oh, so this is how we do it now. Midpoint now of M and all that. Okay, now we need to find the gradient. So the gradient part would be of this line, y2 minus y1 over x2 minus x1. So we just substitute accordingly, just an accuracy. We need to keep track. So you can take either way. So let's say minus 6 minus 3 over minus 2 minus 4. Aha, so it becomes quite readily as 9 over 6 positive y, so there will be 3 over 2. Okay, now we know all that ready. So we're ready for the equation of the line. So these are all points and things, gradient that relates to PQ. So y equals to mx plus c now. Let's substitute please to find the value of c. Y is negative 3 over 2, x is 1. Oops. Please take note, y is negative 3 over 2, huh? X, y. M is 3 over 2, x is 1, plus c, from which we can easily deduce that the value of c should be c equals to minus 3. You bring the other side, minus 3 over 2, minus 3 over 2, minus 6 over 2, or minus 3. Done. So now we're going to write the equation of the line. Okay, please take note. The equation of the line would be y equals to mx. M is 3 over 2x minus 3. So this is the equation of the perpendicular bisector of PQ. This is the equation. Huh? Okay, that's it. Thank you.